the SARC website. So don't worry about that. So I'm gonna go over a little bit how to study for the final, or my suggestions to study for final. Main thing is always use Arup Guha's website. It's always useful. So you go there, you go under to his archives, find Intro to C, and he has all his practice problems and exam problems there. There's, do all the examples in the back of each chapter, the course textbook, not including the Python stuff since we didn't cover that in this course. So anything that's not Python is fair game for this test. And also review your assignments at a minimum. So, how Boswell intended for each assignment, they tested you on the material taught that week. So, if you can do the assignments over again, then you should be able to, do well on the test. So since all the assignments help prepare you for your test, the material. Review all the lecture notes, because, he goes over everything that's going to be on the test that could be tested on, and do the example problems at the back end of each lecture slides. And also I use this thing called a 50-10 or 420 method. So what that means is you study for 50 minutes, take a break for 10 minutes. So it's like a good way to break up your study so that you don't get burnt out. And if you had to study for 8 hours straight, you don't want to sit there and study 8 hours straight and then have a break. And then say you have to study more, you'll get burnt out. So if you try doing 5-10, that should be a lot better. You do something for 10 minutes, study. Do something for 10 minutes and study. Try to make a schedule. So this week I'm gonna review the lecture notes this week, or this day I'm gonna do practice problems, and then I'm gonna review the lecture notes again, and so forth. And then always get sleep. It's always important. So some things you can do during the final. Always ask questions during the exam. If anything's ambiguous, if it's a typo, or if you're just confused what the question is asking, it doesn't hurt to ask, just to get clarification. You don't want to answer the problem, and then it turns out you didn't understand it correctly. And always put something down if you don't know exactly how to solve the problem entirely. So what that kind of means is you get partial credit for anything, or most things you put down. So as long as it seems like you're going in the right direction, you'll get some kind of credit. If you put nothing, you don't get no points at all. So always try to put at least something if you don't know how to solve it. And does he give you the like an extra sheet of paper during the exam, like a notes paper? Did he say that? So yeah, one thing I would do for that, for that little sheet of notes or 2 sheets of notes, if he gives you that, don't actually put down solutions to certain problems or syntax, because the problems on the test is not going to be any homework problem or example problem he's given you. He's not going to make it that easy. So putting that solution, trying to memorize that solution, it doesn't really help you. It's just going to waste space on that paper. So the thing I would do is put like all those little libraries, so string, math, the standard lib, and C-type, which is right there, those 4 libraries. All the functions from that, all the ones you might need. So like from math, there's the power function, square root function. String, you have the string copy, string compare, and all that. And put down how it all works. And any other useful functions or things that might help you. Or and this is only if you 100% get the syntax. If you don't get the syntax of certain things, like how for loop works, obviously it doesn't hurt to put that down. And try to start with the easy problems first. So, when you get the exam, I would say try to actually look through the entire exam and try to pinpoint all the easy problems. At least with the ROOP, the previous exams he has, it all generally starts easy and gets harder. So, that makes it a little bit easier. But if he doesn't do that, it'd be more beneficial to try to look through and find the problems that you know how to do or that are easier so that, you get those points. Now, if you get stuck on a really hard problem, you say you spend an hour on one problem, you still got 9 more problems to go, and you only have an hour and a half or something like that. So you don't want to waste too much time on one problem. If you get stuck, try to do other problems as well. And this kind of goes with the little cheat sheet thing. Try to use, don't fill up the entire paper entirely unless you need to. You can have extra white space, or use the extra space on the test, and you can write down any diagrams, tables, any pieces of code that might help you solve a problem. So any like ideas or pseudocode that might help you solve a problem, you try to write it down. Whenever I try to solve a problem, I don't just straight sit there and try to solve it in my head and write it down. I always try to write down diagrams or graphs or tables to try to help understand the solution. So that would definitely help. So what I have next, I have 10 essentially practice problems that I've taken from the previous exam, and these are all courtesy of Rupa Guha. I don't take credit for any of this. So, and all these problems, I try to pick out certain problems that tackled every topic. So all the major topics that you need to know, like if statements, for loops, strings, 1D array, 2D array, and all that, linked lists, structs, and all that. I have a problem for each one of those. So we're going to try to go through it. If you have any questions, raise your hand and ask. Okay, let me make sure. So there's this first problem here. Can everybody see that? Okay, that's here. I'll try to make it slightly bigger. Yeah. Here we go. There. So this one is asking, how many times is the letter N printed by the following print statement? So this might seem pretty easy, but more than likely there'll be at least a few questions that are kind of like this, where it should be relatively easy points as long as you understand a couple basic rules. So the first thing to look at, or first thing to notice, is there's a lot of these little slashes. So what does the slashes do? So the slashes pretty much mean like an escape character. So whenever you see an escape character, or one of these, the next thing that follows it is an escape character of some kind. So this first one here is just going to print a backslash. That's all it does. These are new lines. The thing that when the N follows a backslash, it represents a new line. So what do you guys think? 7? Anyone else? So yeah, the answer is 7 in this case. So it'll print out the first 2 ends, and then it'll get here and then print out a slash. It'll print out these 2 ends. That's 4 ends total. And then it'll do a new line character, which is not a visible character. And then another new line, one more new line, an N, another new line. There's 5 ends. The new line, the 6th N, another backslash, and then the 7th N, and then another new line. So there's 7 in this case. And I have it, I made a C file with all these problems in it to try to help illustrate what it, to show you that it works. So I have the exact same problem here. It's just going to print out the exact thing. So if I run it, hopefully it shows up nice and good. You can barely see it. I don't know if I can make this bigger. Nice cursor. Yeah, it's not very good. All right. You can't really, if you could see it, it prints out 7 ends. So there's 2 ends, a slash, another 2 ends, bunch of white space, N, N, slash, N. So there's that one. So there would probably be a few small, easy questions like this. But there would be easy if you understand certain basics. So, if you remember, what a slash is, what a slash N, slash. If I put a slash, comma or slash quotations there, this actually print out 8 N's instead because it'll escape that quotations out and then print another N there. So knowing those little basics, then there should be a bunch of problems kind of like that. So there's this second problem. So it says, given that the values of the variables a, b, c, and d are 13, 7, 18, and 9 respectively, what is the value of this expression? So a will contain 13, b will contain 7, c has 18, and d has 9. The question is asking you, what does this give you? If I printed that out, what would that print out? So you're given A plus B does not equal C, and C minus D does not equal D. And then in parentheses, there's another exclamation out there. I believe there's like a kind of question like that trip people up on one of the previous tests. Give you guys a second. You think it's A? All right. We'll see. We'll go over it. Anyone else? Okay, so the first thing, so if you remember order operations, you don't have to remember the order operation table exactly, but you should have a general idea. Parentheses are always first. And whoops. So the first thing you have to look at, you go inside the parentheses, and then there's one more parentheses here you have to deal with. So A plus B. A plus B would be 20. So you're saying, is 20, what is the result of this expression here? So 20 does not equal 18, so that would give you a 1, I believe. No, 20 does not equal. That's true, yeah. Yeah, that will give you a 1. And then you have to look over here. What is C minus D? So C is 18 and then D is 9, so 18 minus 9 would be 11, does not equal D. And that's true. So since both of these true, oh, okay, yeah, so that's false, sorry. Yeah, sorry. So 18 minus 9 is 9. 9 does not equal D, so that is false. So this whole thing would become false because you need 2 truths in an AND statement to make it true. Anything else is false. So, this whole thing would be 0. So you would just have the not sign in 0. So then that would reverse it to 1. So the answer would be B in this case. You always try to solve what's inside the parentheses. These would be lower operations. So you do what's on the left and then the right. You try to solve it and then solve everything. 1 is true, 0 is false. So the other thing in C, I believe, any number greater than 0 is true. If you negated that, it would become 0. So even if this became 20, when you do the negation, it turns it to 0. Yeah, the exclamation point is negation when it's by itself. So this little exclamation point out here negates everything. So it changes it to either 1 or 0. That negation symbol on the left. The one on the far left, it pretty much says that's negation. Yeah, that's the mission going out here. That would negate everything within it. So if it's 0, it would negate it to 1. If it's 1, it will negate it to 0. When you have the exclamation point equals, it says, does the thing on the left not equal the thing on the right? Yeah. So I got that one too here. It's the same problem. I just set the 4 variables to 13, 7, 18, and 9, and then I just try to print it out. So whatever this will evaluate to, I'll print it out. And you probably can't see it in here again because of stupid. So. Yeah, 18 minus 9 is 9. Yeah. Yeah, I did my math wrong. Yeah. For some reason I thought that was like a 7 or something. So 18 minus 9 is 9. 9 is equal to D, which is 9. So this is a false statement. So yeah. The other thing that, say if I made this a false statement on the left side, so A minus B, I want to make it here. I want to make this a true statement or a false statement. So right here, C is equal to C, obviously. So that's false, correct? So because that's false, do we have to evaluate the right side? So yeah, the compiler doesn't care about the right side, because if the left side or right side is false at any time, it's automatically false. This is called short circuiting. So if the first thing's false, it doesn't care about the thing on the right, because it's still going to be false, the whole statement. So it forgets about it. So this next problem, there's actual coding involved. So this one is assuming that numbers.txt, I'll make it bigger. Yeah. All right. Assume numbers.txt is a text file with non-negative integers, 1 per line. -1 is at the very last line. To indicate the end of the data. So the thing you have to do is write a segment of code that opens this file to read from, counts how many of these numbers are between 90 and 100 inclusive, and prints it out to the screen, and also closes the file. So, we have to read from this file. That's the first thing you have to look at. This right here does not necessarily matter to us, non-negative integers, but or it does matter actually, because the last line is going to be a -1. So every value is going to be positive. Once you see a -1, that's the end of the file. So you have to read from it, count the numbers in it. So there's another thing, we're counting something. And also we only care about the numbers between 90 and 100 inclusive. So if you don't know, inclusive means it includes that number. So it could, you care about a 90 and you care about 100. If this was exclusive, 90 and 100 is not included in what you're looking for. So that would be 91 up to 99, but this problem is inclusive. So it's 90 all the way to 100. And you said print it out and close the file. So here, who remembers how to open a file? Yeah. Mm-hmm. The quotations. Yeah. Mm-hmm. So why R? So yeah, for fopen, the first thing you pass in is the name of the file or the path to it. And the second thing is what you're doing with the file. So are we reading it? Are we writing? I'm trying to make this a little bigger. Oh, I can't do that. It's gonna. Okay. Yeah. There we go. Yeah. All right. So if you wanted to write to a file, you just change that to a W, and it's R for reading. So we're just going to open it and see what's inside of it. So what would be the next thing it would do? What do you think? So all we're doing is reading the file and counting how many numbers are between 90 and 100 inclusive. Yeah. Mm-hmm. Mm-hmm. You got it. Yeah. I'm just reading it too. Mm-hmm. Yeah, that's really good. So yeah, so you have to go through the entire file. So we need some kind of loop though to go through it, and then you want to scan in every number, and just like you said, have an if statement that checks if it's within that bound. Yeah, there you go. That would work too. So let's say int num. So this is a number we're gonna put it in equals um, 0 in this case. I want the 1 1. So yeah, f scan f. So then what goes in here? Okay. Oops. So yeah, very less than or equal to 100. Is there anything wrong? Mm-hmm. Yeah, exactly. So you have to make sure you put the name of the file in there. Yeah. So the one way to easy to remember that is like if you think of scanf, you would just do it that way. When you put the f in front of it, you have to put the file name in front of that. IFP is just the name you're giving your file pointer. Um, I think that means input file pointer, but you can call it whatever you want. Yeah, you can call it that. You can call it FP, whatever. It's just a file, variable name. Yeah. I think it stands for input file pointer, but it doesn't not important. Yeah. So then you said we're just gonna do count plus plus. So what's going on here? We're gonna just see the whole thing. All right. So we're gonna first open the file. We're gonna read from it, and then we're gonna keep count of something. So we need some kind of count variable and something to store your numbers in. You also need a loop to go through it since we don't know how big the file is. So we need to go through it. We're going to scan every number in, and it's going to store it into num. If that variable, whatever's in num, is greater than or equal to 90, and is also less than or equal to 100, we're going to increment that count, since that's something we're looking for. If the question was asking about, in between 90 and 100 exclusively, you would just put the less than and greater than. But since you're including those numbers, you have to make sure you put greater than or equal to, less than or equal to. And then the last two instructions for that problem, you have to print out the number, whatever count is, and also close the file, which is just like that. So it's fclose and whatever the variable name is. That's good. So I've written a little test for it, so it's here. So what this will do is just print out the fact that it's prom 4, which that's not the right prom. It's actually prom 3. Oh wait, no, I didn't do that. Never mind. Oh yeah, I have a text file, I'm sorry. So let me open that real quick. Oh well, I don't worry about that. I made a text file for it, so we can test it. So this is prom 3. So it prints out 10. I should probably get the actual text file. Numbers. So this is the text file. So I put 1, 2, 3, 5, 169, 15, 35, blah, blah. And then the thing ends with -1. So the main thing, looking here, these are the only numbers in between 90, or close to 90 and 100. So I have 90, 95, 100, 99, 92, 93, 94, 96, 97, 98. So if you count these, there's 10 of them. And then there's 101, so it should be just 10. And then when I run it, if you can even see that, it prints out the number 10, which that's the count. Any questions about that? Yeah. So this works out fine. The way I did it when I solved it is I just did, well, it does not equal -1. Either way it works in this case. Once it finds -1, it's going to end. But I mean, doing your way is actually a little bit better because, say if the person did put a bunch of negative numbers in there, it wouldn't care about it, so it would get out. But I mean, either way works in this case. You mentioned before, there's one thing some people start doing with, because of like math or whatever, would this work at all? So yeah, so since you can't do the instant C, so you want to make sure you can't just put this in the middle. So if num is greater than or equal to 90 or less than or equal to 100, it'll do what you want. You can't do that. You have to do like this. So you first check if it's greater than or equal to 90, and check if it's less than or equal to 100. So you want to make sure you use those. Okay, so next problem. This one's quite a long little problem. So this is a problem with arrays. So it reads, Superman must leap up and down a whole skyline of buildings in order to keep Metropolis safe. It takes him no energy to leap down from a tall building to a shorter one, but because he can glide down. But he does expend energy when he jumps up from a shorter building to a taller one. You must write a function that takes in the heights of the buildings and feed them in feet in an integer array, along with the length of the array, and return the total number of feet Superman must jump up if he jumps up from building to building, in the order given. So for example, if there were 6 buildings, and the heights were 1,000, 800, 750, 900, 800, and then 900 again, and then Superman would have to jump up a height of 150 from the 3rd building, which is the 800. I think I messed up something. Wait, no. So from 750 to 900, that's 150. And then he has to jump up another 100 feet from the 800 to a 900 one for a total of 250. So if you're given this data in an array, you would have to return 250 in that case. So the one thing to notice here is you only care about positive differences. So you don't want to calculate and add this number. So from 900 to 800, if you did 800 minus 900, I'll give you -100. You don't want to add that to your thing. You only care about positive differences from 800 to 900. Whoops. And then that's the function prototype you have to do it in. So distance jump, you pass in this array. So that's an integer array, and that's the length of the array. And then you have to return an integer. Okay, so yeah, I made this little testing thing, so it's going to print out the fastest problem 4, and then it's going to print out, I make an array that has the exact same values from the example, and then I will pass that with the size of 6 to this function. And that will print it out, so that should test it. So then we want to write our solution here. So what do you think we should do? Yep. So we're obviously going to need some kind of loop. Make sure we initialize our I or whatever to go through the loop. We have to, we're given the length, so we want to make sure we go through. So what this would do, you would start I at 0, and then you're going to keep incrementing I by 1 until this is false. That's how a general for loop works. You start with this, and you end with that. You end at this point. So once this becomes false, it ends. So if length is 6, I is going to equal 6, and then it's going to this becomes false, and it breaks out. It doesn't do anything when I is 6 in that case. So if you're past the array of file or an array of 0 length, it doesn't do anything. If you pass the file of huge length, you want to still be able to handle it. So don't get mixed up with the example. Even though the example has 6, you don't want to put the number 6 here, because it says that you're given the length of the array. That's just an example. It can be of any length. So you want your thing to go that entire length. So what should we do now? Mm-hmm. Yeah, that's good. Okay, so yeah, that's good. So the one thing, we're going to have to count, so obviously we're going to need something to count the stuff. So you can call this whatever, I just call it distance. So the first thing we're going to do, since we're trying to figure out, we're trying to determine what are positive differences in this thing. So we have to go through it and check, is he jumping up or jumping down in this case? He's jumping down, since he's, it's a negative difference. If you did 800 minus 1,000, that's a negative number, negative 200. And then if you looked at 800 and sent 50, that's still a negative, that's negative 50. So you just sent 50 minus 800. And then you looked here, 900 minus 1050, that's positive 150. So we want to count that. That's a negative. And then this is 100. So that's how you get 250. So we want to go through our array. Whatever the value ahead of what we're looking at, subtracted from the value we're looking at. And we're going to we want to see if that difference is greater than 0. If it's greater than 0, it's positive. If the button's the same height, he didn't jump up or down, so we don't care about that. We only care about if it's a positive difference. And then we just want to add that to our distance. So you can do this 2 different ways. You can have this on like a separate line where it calculates this value. So say if I did int difference, and I did this here, that'll equal that. So you're going to get that difference, and then you're going to see if difference is greater than 0. And then it's going to add that difference here. You can do it like that, or you can have it where this is in here, and then you add that to it. You don't have this line. Either way would work. So you're just trying to see if that difference is greater than 0, and then if it is greater than 0, you add that distance to, the actual distance counter you have. Either way works. This way might be slightly preferred, because you don't have to calculate this twice. But either way works. And then we want to return an integer because our function's type is int up here. So the int distance jump, we want to return an integer. In the prompt says we have to return distance, so that should be fine. So we can test that out. So if I pass in that array in a size 6, this should give me the same thing, 250. And there's a problem there. Oh yeah, that's right. I was going to bring this up. So, if I is equal to 0, we're going to look here. I plus 1 is going to look at the next one. it's going to keep doing that. Then eventually I is going to be equal to this one. Since that's the fifth index, or yeah, that's index 5. Arrays are 0 index, go from 0, 1, 2, 3, 4, 5. I is going to equal this one, 900. But then I plus 1 is going to be the actual value 6. So at that point, if you put the number 6 here, that's out of bounds of your array. Since building is only of size 6, that's only values from 0 to 5. So you don't want to do that. So you want I to stop at this value. I plus 1 will look at this value and subtract. So the way to avoid that is just do length minus 1. So that this would stop at 5, this would be 6, and then you break out. You don't want to do any more after that. I believe that's the issue I was having. I didn't. Okay. Oh. This was in plural. Oops. So what problem do I want? What is this for? So it prints out 250 if you can see that. So if I change this to 600. So 800 minus 600, that's 200. That's not a positive difference. This is a positive 150. That's not a positive difference, and that's a positive difference of 100. So this should, changing like this, I should get 450. And it does. If you can read that. All right, so any question about that? So then problem 5. So problem 5 is, write a function that takes in a string and returns 1. The string is a palindrome, and 0 otherwise. So a palindrome is a string that reads the exact same forwards and backwards. So what that means, like say, so a race car, for example, R and R is on R, R, A, C, E, R, A, C, E. So it's the same word that it is backwards. So if I reversed race car, it's the exact same. If you reverse madam, it's exactly the same. So we want to write a function that determines if it's exactly the same. So if I change this to D, your function should say that's not a palindrome because the D is not the same as R and so forth. So you're given a string, you call it word, or a character array, and you're passing it to this function. Okay. So the first thing you should try to remember is a word or any string is null terminated. So what does that mean? You have a question? The one thing you should realize is a string is null terminated. There's always a null character at the end. The null character is that little /0. So that's at the end of every word, every string, I mean. So we want to, we're not given the length, but we can iterate through our string using that fact that it's null terminated. So we just keep looping until we find it. So this is going to involve looping again. And then we're going to loop through our thing until we find the null terminator. So how do you guys think we can solve this problem? So this problem, you're trying to figure out a string's a palindrome. How do you think we can try to solve it? So one way to, if you wanted to look at this, one way you can determine if it's a palindrome is this: you look at the outer characters, R and R, check if they're the same. Look at A and A, they're the same. And look at C and C, they're the same. And then the middle one's the same as itself, so it's a palindrome. So you want to, thinking like that, you want to somehow look at the last character and look at the first character, check if they're equal, and then keep going inwards from there. Since we're not given the length, it makes it kind of hard. But since we're given So since we know that the string is null terminated, we can easily figure out the length. So I think the easy first step to do is try to figure out the length of your string. So if we loop through our string until whatever character we're looking at within it does not equal the null terminator. Since if you remember, we want to count every character in it. We don't care about the null terminator, so we don't want to include the null terminator in our count. And just do length plus plus. So eventually, this number at this position, at that certain position in Word, but eventually would equal null character. Once it does that, length is the size we want. So say in terms of race car, that should give us 1, 2, 3, 4, 7, the size of 7. But you always remember that there's like a null terminator on the end of the string. So we're going to go look here, that's 1, 2, 3, 4, 5, 6, and 7. We don't want to include no terminator in our count. So that will give us like the length of the string. So that helps us out. So now we have to determine, is this actually a palindrome? So I'm going to start it out like this. So just like how we kind of said earlier, we want to look at the outer characters, R and R, see if they're the same, and work inwards. So if word, the first one we're looking at, so once the loop starts, I is pointing at the first character. So let's see. This is how I did it. I minus 1 minus I, or length minus 1 minus I. So what that is, so what in this case length would be 7, but if you tried to index at, if you tried to access index 7 of this here, you would be out of bounds. This is only indexes 0 to 6. So we want to subtract 1 from that so that we're looking at that character. So if you just subtract 1, you'll be looking at R, but you still want to be able to move what the variable you're looking at, or the element you're looking at inward. So the next iteration, you'll be looking at A, and so forth. So if you just subtract 1, and then you subtract I, at first I is 0, so that doesn't affect our first, what we're first looking at. Next, I becomes 1. So if you subtract 1 from here, you're looking at A now. And then you subtract 2, which is the next iteration, that's what I would be. You're going to be looking at C. And I is the first thing is pointing at C, you're looking at C and you're comparing them. So this will go from the left, you keep going to the right. This one will start from the right and keep going left, comparing them. And then the problem says we want to return 0 if it's not a palindrome, 1 if it is a palindrome. So if at any point going through that loop, we don't find, or any of them are not equal. So say if I changed this to a D and an E or whatever, something like that. Look at R, they're equal, that's fine. Look at here and here, that's equal, that's fine. You look here and here, those are not equal, it's not a palindrome. But if I change here, as again, you look here and here, now there's not equal, so it's not a palindrome. You don't have to look through the rest of it. You want to stop there. Yeah, so you want to, that would be the best approach. There's multiple ways to solve it, but you don't want to have to worry about, trying to figure out if this is a palindrome when you already determined the other two characters don't make it a palindrome. So you just return 0 once you find anything that's not the same. If we get through it, you just want to return 1. I'm going to try this. You guys think this will work? So let's see. This is problem 5. Give me a palindrome, bro. I don't know if you can read that. So if I type in race car, that should say 1. Yep. 1 checks 5 again, and then I'm going to put in wow, this is palindrome, and pass 5 again. That's not a palindrome, so that's return 0. So this works. So one other thing, I mean, this works fine. You can stop at this point, but there's one other thing. It kind of is somewhat inefficient because if you look at just what this is doing, length will equal 7. Subtract 1, subtract I, so that would give you 6. Then the next iteration of your loop is going to be 5, 4, 3, 2, and 1, and then 0 because length minus 1 is 6. This will keep going until it equals 6, so that would be 0. So this thing here will start from here and go all the way down to here. This here would start from I equals 0 and go all the way up to I equals 6. So that would go from here and go all the way up to here. So it's checking if these two are equal, checking if these two are equal, checking if these two are equal, checking if that's equal to itself, then checking if this is equal again, A is equal to itself again, R is equal to R again. It's redundant somewhat. So the only a little change that would make it slightly better is divide it by 2. You want it to only run about 3 times in this case. Check R and R, A, and C, and C. The middle character is always going to be the same. If there was one more character, it would work. So it would check this one and this one, this one and this one, D and A. This is of size divide by 2. Because this takes twice as long, technically. Any little question about that? So the main thing to get away from this is kind of how you would loop through a string. Say if you wanted to modify your string to have something, or you want to get rid of A's or something like that, or you want to try to find how many A's there are. You have to go through the entire string, and this is the way to do it. So you want to loop through your string until you find a null character. So that's the main thing. The main takeaway is, every string ends with no terminator, so you want to keep going until you find that. Okay. I think I have time. So this problem 6, this one's a little bit more involved somewhat. So let's write a function that takes in an integer array called values that is guaranteed to have only integers between 1 and 10 inclusive, and the length of the array, and it's going to return the number of distinct values stored in the array. For example, this array of length 8 is going to have these values: 3, 7, 7, 1, 5, 2, 2, or whatever, 1, 2, 5, 2, 2. So this should return 5 since there's 5 distinct values. There's a 3, there's a 7, there's a 2, and there's a 1. So there's 5 distinct values: 1, 2, 3, 4, and 5. So I just want to figure out how many values are there that are distinct. And this says explain there's 1, there's 2, 3, 5, and 7. So then you're given this prototype. Let's try to figure it out. So the way I did it is by using a frequency. We don't care about that. We only care about the ones that are distinct. So I think, that'll be the best way to do about it. Oh yeah, sorry. Before we do that, I had this alternate way to doing the palindrome thing, and just using the string.h library. So let me make that slightly bigger. So what I do is create a little temp string, and I copy word into it. So I copy word into a temp, and and then I do this function. He hasn't really gone over it, but it's pretty useful. What that is str string, rv for reverse. So what this would do would reverse your string. Yeah. This is available in the string.h library. This is available in the string.h library. Yeah. So those are the only four I taught you, but I mean, I think these would be, you should be able to free to use whatever functions you want. That's available in that library. So reverse is pretty useful. So a reverse temp, and then all you're going to do is compare work and temp. Since a palindrome is the same as it is as the reverse of it, if they're exactly the same, the reverse of the string and the string exactly the same, then I return 1, else return 0. So that's what that does. A string compare, if you remember, if they're exactly the same, the two strings you pass in, it returns 0. If this one becomes before temp, then that would be -1. And if temp becomes afterward, I believe that's positive, or a positive number. Probably positive, or positive 1. So since we don't know if they're equivalent, you return 1, else they're not, so it's not a palindrome, so you return 0. That's just like a little slightly more nicer way of doing palindrome using the string library. So back to this. So this is, again, if you just forgot it, it's trying to count the amount of distinct variable or numbers in array and values. So how does the frequency array work? So if we wanted to use that, how do we set that up? You remember how to use a frequency array? Oh, okay, sorry. I'll show it to you real quick. All you're doing is you're given this array here in the length. Try to determine how many distinct numbers are in that array. Mm-hmm. So yeah. So the one thing you're trying to do is figure out how many numbers occurred in here. So the 3 occurs, 7 occurs, 1 occurs, 2 occurs, and the 5 occurs. So there's 5 distinct numbers. It doesn't matter if it's a duplicate. Mm-hmm. Yeah, kind of like that. Yeah. Mm-hmm. Yeah. So that's pretty good. Yeah. So that's kind of how the frequency thing works. So what you're trying to do, what a frequency array does, is it allows you to count how many things existed within another array. So you're trying to figure out how many occurrences are there of a certain number and value. So I made this of size 11, and the reason for that is because in the problem it says the numbers that can exist in an array is only between 1 and 10 inclusive. So I want to have an array that has indexes between 1 and 10. So that's why I make it with size 11. The size 11 would have every index from 0 to 10. That's why I did that. Mm-hmm. So at this point, so imagine this is our frequency array here, representation. Every these little brackets is a box, and the numbers below it is the index of that box. So this is like, a little array here. So that's what that does. You have a bunch of empty boxes with these indexes. Now, since we're trying to count, just like with a normal count variable up here, for length, we're counting the length up here, we want to initialize it to 0. So that we know if there's 0 occurrences or there's a certain number of occurrences. So we want to make sure our frequency is all initialized to 0. Perfect. So we start from I is equals, I is less than 11, since that's, the size of frequency. We're going to go through it and just do, so that would go through I is equal to 0, you'll go to here and make that, it'll make this 0, it'll go here and make that 0, it'll go into this one, make it 0, and so forth until the entire thing's all initialized, nice zeros. Bam, and then bam. So that's the indexes of those now. So that's what our array looks like, the frequency array looks like. So now that we did that, now we want to actually start doing the counting. Now we're given the length, so we want to go through everything inside of values and count the number, count the numbers that are in there. So we can use I again. So how do you think we can start counting? How would we do that? So there's, no, you don't need another for loop in this case. So all we want to, what this is going to do, we do need another loop, but we don't need it nested in this case. So we want to figure out what's distinct in here. So so we want to go through the frequency array and find the numbers that are in there inside of array, and then increment your frequency array. So the way to do that is like this. So this always gets people a little confused on how this works here. So what this kind of does, so the thing you have to look at is what's inside of these brackets, the idea for frequency. Normally you would see something like this, where there's an I inside of it. So what you would do is go inside the brackets to see what's in there, evaluate what's in there. But in this case, there's another array call values I. So what you would do is you would look at this. What is that value? So if this value, so the first value would be 3. Well, you want to count how many values are inside of an array here. So you only want to go through 8. If this returns 10, if there's a 10 in there, it would go to the 10th index in frequency and increment that by 1. So in this case, yeah. Well, the frequency array, the only way we don't care about going through the entire, we don't care about going through the entire frequency array. We only care about going through the array that's given and see how many occurrences there is. 3, 7, 1, whatever. So at value sub I, at the first iteration through this loop, I is going to be equal to 0. So the first one in our array is 3. So what you can do is imagine that's replaced by 3. So index 3 in the frequency array, you can increment that by 1. So I'll show you. So the first thing it would do is go to 3, increment that by 1. So it goes to 1. There's one occurrence of that. Oh, that's better. There you go. So yeah. So the next value, let's see if this works. Kind of works. Next value would be 7. So you want to go through 7, increment that by 1. Then you find another 7 inside of your array. Increment that by another 1. And there you found a 1. So values at I is 1. And then you pass 1 to frequency, increment that by 1. And then the 2 gets incremented. 5 will get incremented. And then the 2 will get incremented twice. So that'll be up to 3. So that's your frequency array once the loop's over. That's what it would look like. Another way to do it, to make it a little bit easier to think about. Num equals values of I. And then you're just going to put num here. That'll be a different way to think about it. So you're going to get, whatever that value is, and then pass it to here. And you're going to increment that spot. So imagine like this was I or J or whatever, just like you normally would use, iterating through an array. You're going to use that as what you're looking at, and you're going to increment it by 1. That's another way to do it. That's still too confusing. Yeah, so we only care about the distinct numbers in this case. You can use the same problem to figure out how many occurrences of certain numbers occurred, or in another problem to swap numbers, to sort numbers, sorry. But we don't care about that. All we care about is distinct numbers. So what do we have to do if we want to figure out the distinct numbers? Mm-hmm. Yeah, perfect. So we only care about the ones in here that have a 1 or anything greater than 1. The question is not actually saying unique numbers. If it was saying unique numbers, you only care about the ones that have 1 in it. But since a number that's distinct, so any number that's greater than 0 would be something we care about in this case. So you can do the same thing. I equals 0. Oops. I is less than 11. So now we're going through the frequency array. And all we care about is if what we're looking at inside the frequency array is a distinct number that's greater than 0. Then we're going to increment our count variable, which I don't know if I initialized. Nope. So this will go through the entire frequency array. So look here. Is that greater than 0? Nope. So we don't care about that. Is that greater than 0? Yes. So increment count by 1. Is that greater than 0? It's true. Increment count, so it'll be 3. That's not greater than 0. That's greater than 0. It's 4. Not greater than 5, and so forth. So this should give us 5. And then all we have to do is return it. Oops. Since in the problem, you want to return a number of distinct values. So, yeah. So this should give us 5. So this problem 6. So yeah, that gives us number 5. And I created this testing function. So I call problem 6. It'll print out that. And then all it does is create this array, 3, 7, 7, 1, 2, 5, 2, 2, just like in the example. And then I call the function undistinct, the array and the size of it, and that returns, whatever number. So if I, example, put a 9 here, so that should return 6. Close this, run it. And let's call problem 6. So that returns the number 6. Any questions about that? So this next problem is about 2D arrays. So this one, the problem reads, it's a grayscale picture. It can be stored in a two-dimensional array of integers, where the value 0 represents black, 255 represents white. Sure. So then we want to create a mirror image of the picture by reversing the contents of each row in the picture. So your job is to write a function that takes a two-dimensional array and changes it to be the mirror image by reversing each row, assuming that the constants num row and num column store the values of rows and columns respectively in the array. So in this case, you're given additionally num rows and num columns. And that exists, so you can use that. And you're also given this 2D array. And if you remember from, you don't have to pass in the size, the dimensions of the picture. You only need the second one dimension. That's why it looks like that. You only need the second dimension when passing in a 2D array. You don't need both. Yeah. So you have to pass in the second dimension for a 2D array. If it was a 1D array, you don't have to pass in anything. You can just do that, and then usually you're given the length. But since it's a 2D array, you're given that. But you're also given num rows. You could have just put, int num rows here or something like that. Oops. All right, so what do you think we should do? So I define these constants just so that you can see them. And it's the exact same function. I don't know what problem that is. Mm-hmm. Yep. Yeah, so that's a good start. So yeah, you want to have an I and a j. With a 1D array, you're going to go from I equals 0, I is less than whatever the length is. In this case, you need two different loops to go through a 2D array. So you need a j, and then an I and a j. So whenever you do this, the first index is the x. So you can think about the first one as like the x. If you think about a grid, and like similar to a 2D array, your first index is the x coordinate, and your second index is the y coordinate. So, oops, sorry. Yeah, cool. Thank you. Let me get something real quick. Blah 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 blah. This is my solutions and everything. Okay, where did I put it? Did I put it in here? Okay. So I made like an example. So say this is our 2D array. This is the image or whatever. We'll make it a little bit more readable. Bam, 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 and bam. So 1, 2, 3, 4, 5, 0, 2, 5, 5, 3, 1, 5, and so far, huh? A matrix can be representative of a 2D array. A matrix could be representative of a 2D array, but this is just a 2D array. It represents an image. Each of these values is a color number. So the objective is to reverse each row. So this 2D array should look like this, where the 5 is in the front, 4 is there, and so forth. So you're just reversing each row. So whenever you think about this, the first index, you're talking about the row. And when the second index is always the column, so this here. So at 0, 0, you're looking at 1. At 3 and 2 and 4, you'll be looking here. So that's 0, 1, 2, 0, 1, 2, 3, or 0, 1, 2, 3, and 4. So the objective is to reverse each row. So the one thing you can try to think about is how you would reverse a row by itself. So pretend this is like an array on its own, a 1D array. How would you reverse that? Yeah. So yeah, you're on the right track. So yeah, you um, want to get this value and switch it with this one. Get this value, switch it with that one, and that's fine, right? How it is. So that's how you would reverse it. The one good way to do it is using a swap function. Using swap. So let's try to do swap here. If you remember here, I can do swap real quick. So you're going to store A into temp. And you're going to store what's at B, put it into A, and store temp back into B. So that would swap two values. In this case, you want to swap this value and this value. Swap this value and that value, and you don't have to swap that, but you can swap it if you want. Just put it in the same spot. So we need a temp variable to store one of them. So then we have to try to put, just like how we did up here, we want to try to store one of these values so that we can save it, and then swap them, and then use that to, put it back. So we want to store, in this case, we want to store the last value, which is just -1 minus the j we're using. So, if you think about it, j, just like when we did the one that we did, this one here, the palindromes, you want to look at the last value and then work inwards. And you look at this value, you don't want to look at the 1 and the 5, and then you want to work inwards 2 and 4, and then work inwards. So you want something to save that value on the outside. Num columns is number 5. Since this is 0 index, the last index is 4, so you subtract 1, and that would look at this one. Initially, j is equal to 0. Every time through the loop, it's going to increment. So subtract 1 from index 4, and it's going to be index 3. Subtract another 1, and it's going to be index 2, and then 1, 0. Yeah, you want to divide that by 2 just so that you don't, repeat it. Because in this case, the divide by 2 is important. And the reason for that is once you get to here, I is going to be there, and the one thing you're swapping is going to look there. The other thing you're swapping is going to be looking there. And then it's going to go through again. And then you're going to swap this one with that one. And then you're going to swap 1 with 5. So eventually, effectively, if you don't do divide by 2, in this case, you're going to put it back to how it was. Re-swap it back. So next thing, we want to get the value that we put into temp. Now we want to overwrite the value that is in there. Since we saved it in temp, we can freely overwrite that value. So we want to put the exact same thing. Just like up in here, we put this value in there into temp, but now we're free to overwrite it. We won't lose that value. We stored it somewhere. So we overwrite it, and then we put that back in. And that would just equal the first value in this case, or whatever. Initially, it's the first value, 1. So you want to put 5, which is this will give you 5. That would go into temp. And then you want to get this value, which is 1, and put it into there. So after you get to this line on the first iteration, this will be 1. But temp still has 5, so it's fine. So then you do I, j, equals temp. So 5, temp equals 5. So then 5 will go into here. So you swap the out ones. So we're almost there. So then you want to keep working inward. And this thing would do that for you. J would be incremented. And you're going to subtract a larger number. So now you're looking at this one and you want to swap them. So it'll swap 4 and 2, and then it'll, num columns is 6, the number 2 is 3, so it'll run 3 times. So it would try to swap 3 with itself, and it doesn't matter. So eventually, whoops, this would be 5. So that would give you, that should give you this array. So if I try to run it, which problem is this? It's from 7. So if you look at it, 1, 2, 3, 4, 5, 0, 2, 2, 5, 3, 1, 5, 5, 4, 3, 2, 1. It reverses each row. So the 1 is now over here, 5 is over there, so forth. Oh. Sorry. Yes, again, I made a testing function to deal with it. I made a little function to deal with it. And the problem, all you're doing is you're modifying the array. You don't have to print anything or return anything. So we're just modifying it, and that's it. Yeah, I can show you that. So I made like extra functions just so I can test it and show you. So, this will put those values in there into a 2D array. And then I call a function I call print2D, and I pass in that array. Oh, it's right here. So it goes through the entire thing. So I equals 0, I is less than rows, j equals 0, j is less than rows, and it'll print out every value with some blue lines, just so it formats nicely. So this here would be the way you would go through an entire 2D array. So if you have a problem that says, go through a 2D array and change everything, or replace certain things, whatever it's asking you. If it requires going through a 2D array, you want to use this type of structure, where it's a double for loop, just like this, and you put whatever you're doing inside of here or wherever. So this is how it would be. You would go through a 2D array, generally. For this would be the number of rows and number of columns. So the function. What would happen is, I make it, and then I call this function. It prints it out, just how it is. Then I call this function make mirror, and I pass it in. And the thing is, if you remember, like with pass by reference and pass by value, since this isn't an array of some kind, you don't have to explicitly put the and sign there to do pass by reference. And since it's an array, you don't have to do that. So once I call it, it'll do this stuff, it'll modify it, and then it's saved. And then when I print it again, it'll print out the modified thing. So with arrays, you don't have to do the ampersand to have pass by reference. But like if this was just like int, Bob, just a plain integer, and I was passing in Bob, and if that worked, you'd have to put, star, and then you have to put the ampersand for it to be modified for pass by reference. Arrays, you don't have to do that. So another thing, I guess, to make sure you know the difference between pass by reference and pass by value. When to use the stars, so like in this swap function, I had to use star A, star B, because I'm trying to access that value within that pointer, or what B is pointing to. I'm trying to access that, and then I want to store it into what A is. Any questions about that? Okay. Making good time. So, next problem. I got 2 more after this. So this is problem 8, and this is involved structs. It's a basic struct. So the struct shown below stores a fraction, and this should be the word function. Methods for something else. So write a function that takes in 2 struct fractions and returns a struct fraction representing the sum of the 2 input fractions. Do not reduce it. So an example would be this. So if one fraction is 1/2 and 3/4, so on to get 10/8. So you want to use that kind of method to do addition. So you're given this struct. It has two attributes in it, num and den. So this will be your numerator, and that's your denominator. Then you have this function down here where it passes two structs, and you have to do that operation, adding them. Real quick, what is the other way to make a struct definition? So the other way to make a struct definition would be using type def. So you can do type def struct, and then you can put the name, whatever you want to call it. So I want to call it frac. So then anytime I reference it after the fact, I can just put frac instead of struct fraction. So I can replace it like that. But he said he's probably not going to put type def, so I didn't remember that. So struct fraction. So you're creating your own data type. That's what structs are for. You're creating your data type that's storing a number, two integers in it. Okay. So the first thing it says is that you want to. So what you would do is you want to write a function that takes in two structs, and you return a struct that represents the sum. So you want to return the sum of these two. Oops. Down here. So how do we access something within a struct? Mm-hmm. 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 Yeah, so that's good. But the thing that you can, I guess, realize so there's two different ways. So let me see. So say if I wanted to access ops1 thing with the thing inside it, you're saying use this to do it. Mm-hmm. Yeah. So that's good, but that's only good if this was a pointer. So if these are pointers, then this would be fine. It's either you can do it this way, or we can do the alternative way and have the little arrow. So if it's a pointer, you can do it that way. But if it's not a pointer, what do we do? You remember the operator to use to do it if it's not a pointer? If it's not a pointer, you just need the little dot operator. So that will give you access to num. So how we do the addition in this case? So the thing with this problem, you have to remember a little bit of basic math. So how you would do sum, first you have to find the common denominator between them, and then you add them together. So you would find the common denominator between the 2 and the 4, or the thing that's in common. So that's 8. So if you, the first thing you can make it is 4, but it makes it a little bit easier if you just do 2 times 8, and then add it with the numerators. So I probably didn't make much sense there. So I want to create another struct fraction. That would be our result. So I need the easiest one to do is the denominator. So that would just be op1's denominator times op2's denominator. So doing this here, that should give me the 8 on the bottom. 2 times 4 would be 8. Next thing I do want to figure out is the numerator. How do we get 10 from this? So you want to make this have a common denominator as this one. In this case, we want it to be 8. So 2 times 4 will give you that. So you also do the same thing to the numerator, 1 times 4. And then you do the same thing to this one. In order to get this to 8, you multiply by 2 on the bottom. And you multiply by 2. So this will be 6. You add 4 with it. I'll give you the 10. So we want the result numerator equals op 1's numerator times it by the op 2's denominator. That will give you the 1 times 4. And you want to add that with the other one. So it'll be op 2's num so then that would work. So you get the numerator times by denominator of both of them and then add it together. That'll give you 10, and the denominator is 8. So that just works out fine. And I have a function somewhere, this one. That does it for you. So I create a struct fraction first. I set it to have 1 and 2 for numerator and denominator. And I have a struct fraction second. I set it to 3 and 4 for numerator and denominator. And I just pass those two things in to my add function. I get that result, and I just print it out. So this would print out the numerator of a result into here. It would print me a slash just so I can have a little fraction representation, and the denominator would go into there. So if I run it, it should give me 10/8. It's probably 8. There you go. So that gave you 10/8. That's what we wanted. So if I change this to 4, that'll probably be something, I don't know. 8, it'd be 16 over 16. 1 times 4 is 4, 4 times 3 is 12, so that'd be 16 over 16. Since, if you can just look at it, 16 over 16 is the same as 1. If you add it, since these already have common denominators, 4 and 4, you just have to add the 1 and 3, so it'll be 4 over 4, which is still 1. So it works. Then now, you got problem 9. We'll see. So I guess we'll do problem 9, we have time. Yeah, the last one's a linked list problem. So problem 9 says a single tile that can be represented by the following struct. You got type def struct, char letter, and end points. And then I call it tile t. Write a function that takes an array of these tiles and the length of the array and returns 1 if the array is sorted by either letter or point value from smallest to largest and 0 otherwise. So in this example here, you want to look at the letters A, B, E, Z, and see if that's in order. In this case, it is. You're also going to check, if the numbers are in order, 1, 3, 1, 10. That's not. But since the letters in order, it's, either case works. And we want to have an array sorted by either letter or point. In this example, E1, A1, and B1. The letters are not in order, E, A, B, but the numbers are 1, 1, 3. That can be the same. But in this one, neither of them work, so it returns 0. J, A, and Z, it's not in order. 8, 1, 10, it's not in order, so it should return 0. So let's of that array. So that's this here. So this one's pretty straightforward. So it's the same exact thing. Since we're looping through an array, you just want to have, a for loop that goes through it int I. So for I equals 0, I is less than our length. This we want to go through the entire array. pretty much just want to check to see if if either the letter we're looking at, so if we're looking at A and B, we want to see if that's in order. We also want to check to see if this is order, or we don't want to do and. Both, we don't need both of them, we only need one or the other one to be in order. So we want to see if the rank of times so that, since it's just an array, you want to use it, you want to access it just as an array, but since it's a array of structs, you have to do the dot letter to access a certain attribute within it. So we want to see if the letter, the one on the head of where we're at. So if we're looking at this one, we want to see if this one is greater than A. So that's how I determine if it's in order, greater than or equal to. So since it's just letters, you can do the normal comparison. And then since the question also says or, we want to also check to see if rack of times dot points is greater than or equal to the one you're looking at, the point you're looking at. And then if any of those points, if any either at any time you find one is not in order, then the thing's not in order. So, once you find something out of order, and you want to stop, you don't want to keep looking through it. So that's why we would do this here. So if one of these is true, this whole thing will return true, and then we do not on it. So that would give us 0. I mean, if one of these is true, that'll give us a 1, and then we not it, that would turn into 0. Then we do return 1. No, I didn't. So, oops. So if both of these are false, this will give us 0, and you not it, that'll become 1. Since both of them were false, that means something wasn't in order. Neither of them was in order. So we just want to return 0. We don't want to keep going through it. If we make it through the entire thing, then we just return 1 since it's in order. Just we went through the entire thing, we didn't find anything out of order. So then we run it. And that gives 1. And I passed it the same thing. So I passed it 3 of those little tuples. So an E and a 1, A and a 1, and a B and a 3. I created my little array of structs. Just like in here is A1, B3, or no, E1, A1, and B3. I pass that into here. It's of size 3. And I'll print out whatever value that gives us. That gives us 1. And I made another case that should give us 0. So that's the other example. J and 8, A and 1, Z and 10. So that should give us 0 because the number's not in order. And so aren't the letters. They're not in order. It's the same example here. So if I recompile it, 9, and then give us 0. So now we're going to the last problem. Next problem reads, write a function that takes in a pointer to the front of a linked list and exchanges the value stored in the first and last nodes of the list. Do not move the location of the two nodes in the list. If the list has fewer than two nodes, nothing should be done. So the two things we have to do, looking at it, we have to exchange the values in the first and last. But we also have to make sure we're not moving in any actual node, and make sure that the list is greater than two or greater. So again, this one is just a basic, using the same concept as a swap function. So the first thing we need to do is have a temp variable to store one of the data that we're going to override. So in this case, we can just store the very first value. I didn't do a thing. I thought I did. So we store one value stored in temp, and then we want to be able to go through. We want to be able to go through our array or our linked list. And the way to do that is using again a temp variable. We're going to point it to the head of our linked list. While this temp variable, while next does not equal null, so this is the way to go through a linked list. So if it'll keep going through temp equals temp, next. So the temp variable would point to the head of the linked list, and then it would point to the next variable, and it'll keep doing that until its next does not equal null. So at this point, temp would be pointing at the very last variable, or the very last element of the linked list. So then now you have temp is now the last element in the linked list. So now you want to do the swap. So now you take the last value, store it into the first value, and you have the first value, you say it in the temp variable. And now you just want to put what you said in the first one into the last one. So this is like this here, and these two here is the swap function. This is how you get the last variable. So that would swap the two values in your linked list. So then I created another test function, called it problem 10. I created my linked list. So what I did is star my list equals create LL. So I called a function. So what create LL would do is return, the return type is struct LL star, so it has to return that data type. So then I do struct LL equals null. I want to populate my linked list with random values. So then, you first hit the malloc, the space for it, for your temp. And then I'm going to get a random value between 1 and 10. And that's how you would do that. %d will give you a value between 0 and 9, and then you add 1 to it, it will give you a value between 1 and 10. I put that into the temp data, and then I assign that to, I give next. Next would be null. And I say my LL would equal temp. That's what the thing we just created. My LL would now equal temp. And then I should return that. So this will get returned, everything I created with the random values. and get stored into my list here. So then I print it out. And what that function does is, again, you use a temp variable to go through it. So it looks at it, first it points to head, and keeps going until temp does not equal null, or until temp does equal null, and it'll print out every number. There's a new line at the end. No, that's why I called it a 2. You can't call it the same even though it's a different data type. It's weird. So there you go. So then it spawned the last value and the first value. So the 4 is now over here, and the 3 is now on the end. Everything else has stayed the same. So the last thing, how I did all this was I had a main function, the switch statement. I got input from the user. What do you want to check? What problem you want to check? And got the answer, and then just try to figure out which one you want to do. So if you enter a 1, it's going to do problem 1. If you enter in 10, it's going to do problem 10. And just keep going until I enter 0. So whenever I enter 0, it'll end. So that's the main function. So that's pretty much it. So that'll be pretty much it. So I have a little survey for anyone that's actually here for my session. People started leaving, so. Do you have any questions for me? All right. So this will be made available on the SARC website. So if you just Google SARC SI site, so you can find it. You just click here, go to Engineering and Computer Science, and then find interesting programming with me. I have the PowerPoint I just showed you, all the solutions with comments to explain everything, in that little text file that I use for problem 3. And then there's a link to find this recording.